Welcome to my AP Stat tutorial on Chapter 25, Paired T-Tests. This is our reading example from our Chapter 25 reading guide. The big difference between Chapter 25 and what we've done before is we don't have independent groups anymore. We have one group, and we take a before and after reading. So the groups aren't independent, but the differences are independent because the difference of Alan's before and after pulse rate should be independent of Brandon's, and so on. So this is called a matched pair t-test because it's on the same subject twice. Now, in our reading exercise, the example asks if there is evidence that the exercise device helped reduce the pulse rates. So the way we start this is I always like entering data into my calculator, so I will usually put the before in L1 and the after in L2. And we'll use L3 based on the hypothesis. So let's take a look at the 4 steps. So our hypothesis looks a little different. We're going to be using this little symbol, mu sub d, to denote the difference of the mean difference of the before and after. So if there is no difference, the null is 0. But if there is a difference, in this case, we're going to have a lower tail test. We want the difference to be negative because we're interested in the decrease. So to generate this histogram, remember I put the before treatment is in L1, and then the after treatment is in L2. So I'm going to do L2 minus L1 and stick it into L3. So I'm going to run my histogram off L3, and I'm going to run my one variable stat on L3, and I'll get that as my mean, and that is my standard deviation of the sample differences. So conditions. Once we've got the hypotheses down, the conditions, we need 3. Pair data, and that's based on the context of the question. Independent assumption of the differences. So it's reasonable to assume that one subject's difference of pulse rates is independent of the other subject's difference of pulse rates. And then the nearly normal condition is just on the differences. So in our case, it's unimodal and roughly symmetric. Now we don't need a 10% condition here. And notice in the stem of the question, it wasn't a random sample. We had volunteers for this little survey. So the scope of this study is very minimal. If we wanted to broaden the scope, then we'd have to draw a random sample from the general population to see if this device worked. But we don't necessarily need to have a random sample to run a paired t-test, especially if we just are interested in the subjects that we test. But if we wanted a broader scope, we'd have to do a much larger sample and a more representative sample, meaning a random sample. So the mechanics, pretty much the same as what you saw before. Our standard error is going to be the sample standard deviation divided by the square root of your sample size. And that's what we have right here. And then you find your t statistic, and then you use TCDF. You're going -99, -3.5, and then degrees of freedom 9. It's one less than the sample, than the number of pairs that you have. And then we get our p-value. So the conclusion and the confidence intervals are the same as you would do in Chapter 23. So let's take a look at those. So it's a statement about the null. Strong evidence that this form of exercise can reduce resting pulse rates among this group of people. If we wanted to be more broad, then we'd have to take a random sample of more people. The confidence interval is similar to what we did in Chapter 23. I asked that you use a 95% confidence interval. So that's the setup. There's your t-critical for 9, and there's your standard error. And the interpretation of the confidence interval is the same as the ones in previous chapters, except there's no comparison here like in Chapter 24. And notice that the interval is below 0, so that means the resting pulse rate actually decreased based on this device. So I hope this helped. If you have more questions, please bring them in tomorrow when we hit Chapter 5 running. Until then, see you later.